How do you solve a quadratic equation using the square root principle? So what are the big ideas to keep in mind? First of all, to undo a square, and square, remember, means raising a number to the second power, you take the square root. So the square root of x squared is equal to plus or minus x. Remember from your study of radicals that whenever you have an even root index, in this case square roots are even, the root index is 2, you always have two solutions, a plus and a minus, a positive and a negative. Another idea to keep in mind is that this method only works under two conditions. One is that you have only an x term. In other words, you have no x term. You have only an x squared term. Or your quadratic is a perfect square trinomial. And we'll look at examples of both of those. And in fact, let's look at an example of what I mean. Here is a quadratic that has no x term. It's just got an x squared term. That's a perfect candidate for this technique. And here is an example where your quadratic can be factored into the square of a binomial. So that's another good candidate. Do you remember how to simplify radicals? Because we're going to be working with a few. So if not, you might want to go back and review that. Examples. 3x squared is equal to 27. Now, of course, you could use the quadratic formula, but I'll tell you, it is so much easier and you'll make so fewer errors if you use the square root principle on problems like this. The first step is always to isolate the x squared term. So it almost is isolated. We just need to divide out that 3. So we get x squared is equal to 9. Now once you have x squared isolated, you simply take the square root of both sides. We know that the square root of x squared is x, and the square root of 9 is 3. So we get x is equal to plus or minus 3. And that is the exact answer. And I'll talk about approximate answers in just a minute. Another example. First step, isolate the x squared on the left. So that means we've got to add a 5 to both sides. Now we've got our x squared isolated, so now it's time to take the square root of both sides. On the left, we're going to get the square root of x squared is equal to x. And now here's a good place to pause and see if you can remember how to simplify the square root of 32. All right, I hope that you were able to remember. You get 4 times the square root of 2, so we get x is equal to plus or minus, remember that's two solutions in there, plus or minus 4 times the square root of 2, and that is the exact answer. That is in simplified radical form. Now, oftentimes when we have practical problems, we just want to get an approximate answer. So we plug in the radical into our calculator. In fact, you can go all the way back up to the square root of 32. If all we want is an approximate answer, there's no need to go through the simplifying process. So plug in square root of 32 in your calculator. There's often rounding instructions to tell you what place to round to, and that's what is known as our approximate answer. We had to round it off so it's no longer an exact answer, we're just approximating. Let's look at another example. This is an example of where we can use the fact that this is a perfect trinomial square. So there is an x term, and before we decide that we cannot use the square root principle because that x term is there, we want to do one last check. Could we factor this into the square of a binomial? Go ahead and factor it. So you should get x plus 4 times x plus 4. And so let's write that as the square of that binomial. Now we've isolated our squared term. And so now all we have to do is take the square root of both sides. The square root of x plus 4 squared is x plus 4. Now we still have not isolated x. We still got to get rid of that plus 4. So of course we're going to subtract it. And by convention, we write that negative 4 in front of the radical instead of after it. So we get negative 4 plus or minus the square root of 11, and that is our exact answer. That's simplified radical form. Now, if we're asked to find the approximate answer, do remember you need to pull apart that plus and minus. You've got two little problems to work in your calculator. And if you want the approximate answer, let's just say in this case I rounded it off to the nearest hundredths place, then here's the approximate answer. And you might practice with your calculator in case you're a little rusty on finding square roots. All right, one more problem, a practical problem. We're going to go skydiving. We have a formula which gives us the height of a skydiver. So S, the big S, capital S, represents the height. The V0 represents the initial velocity, so how fast is that skydiver going at the beginning of the time that we're interested in? And how high is the skydiver? So that's S sub 0. So here's our problem. Our skydiver is going to get into a plane, go up to 5,000 feet, and then jump out. Crazy. How long, to the nearest tenth of a second, does it take that skydiver to fall that first 1,000 feet? So we want to know how long it takes to reach 4,000 feet. So we've got an equation which will help us. Now we have to figure out, well, what's the initial velocity that we need to plug in? Well, the problem doesn't give us one, so we got to think about that for a minute. The skydiver hasn't jumped yet, so they're not moving. So their initial velocity is 0. In terms of the initial height, well, they're up there at 5,000 feet, perched on the edge, waiting to jump. So that's our initial height. So we're asked about time. That's the only variable we have left. We're going to go ahead and solve. Let's simplify that. We end up with 16t squared is equal to 1,000, and really work that. Convince yourself that that's correct. Now this is a perfect candidate for the square root principle. Let's divide out that 16. Let's take the square root of both sides. And now you don't have to worry about simplifying the square root of 1,000 over 16 because this is a practical problem. We're asked to find the time to the nearest tenth of a second. So plug this into your calculator and you should get plus or minus. Remember, we've got two solutions, plus and minus. 7.9 seconds. That is rounded to the nearest tenth. Now there's one little problem here. Anybody see it? Well, if you said that we can't have negative time, you're absolutely right, at least not in this world. We can't. So we leave out that negative solution because we have a practical problem here. So t is about positive 7.9 seconds. So that's how long it takes this skydiver to get from 5,000 feet down to 4,000 feet. Wrapping up, the square root principle you can use when you only have an x squared term, that is, the x term is missing, or when your quadratic can be factored into the square of a binomial. Works really well in both of those cases. Again, much faster, fewer errors than using the quadratic formula. Go practice.